Well, hey everybody, this is our first recorded lecture. Guess what it's on? It's on section 5.1. I am your intrepid guide today, Rich Weber, and I'm going to guide you through, in this particular section, the addition and subtraction of polynomials. So I've given you notes here, as you can see, and obviously this will be a file that's uploaded to Canvas, and you'll be able to look at it all the time whenever you want to. I'm going to write on it too. Anyway, the thing about polynomials is that these things, if you will, can actually be looked at as an abstract extension of numbers. So, for example, the number 3,438 can be rewritten as 3 times 10 to the third, which is 1,000, plus 4 times 100, plus 3 times 10, plus 8. Why would you do that? Well, look at this polynomial here. That's a polynomial. It has degree 3 because the power is 3. Okay. Then it's got a square term, an x term, and a constant compared to this number that we broke apart. And the pattern is there for you to see, isn't it? Instead of tens, you've got x's, period. That said, the reason I point that out is because when we get into this chapter and start doing addition, subtraction, multiplication, division, we always harken back to what we did with numbers in order to understand what we're doing with polynomials. In this section, the topics are add, subtract polynomials, and here are the notes. Okay, I'm going to go kind of fast, by the way, because I know you can stop, rewind, and all that. So I'm not going to talk fast. I'm just going to not pause. You can pause the thing when you want. Obviously, I can't pause and ask you, do you have any questions? Because that's not how this goes. Anyway, the big story here is to combine like terms. That's the big story here on how to do the problems in section 1. The terms with the same variables and to the same powers are to be put together or combined. Okay, so to combine, the mechanics to remember are, this is what students think about when they do this. You're supposed to add the coefficients and you never change the power. Oops. Okay, I better not lean over there. So let me get rid of that guy. Never change the power. Okay, when you change the power, that's when you multiply over here. This is actually based upon the distributive property, but in reverse. So if someone says, I want you to simplify this, what you do is you combine the terms, because notice it's a squared b4, a squared b4. These guys are like terms. They're the same. But the distributive property says I can actually look at this in a different way, as if someone took a squared plus b to the fourth and distributed. So you can take it out, you can add the coefficients and get your answer, and that's simplified. You get 17. When you're doing the math, it's pretty quick. Okay, subtraction is the same thing, except I've got some nice notes here for you. When you subtract a polynomial, you must subtract each term individually, not just the first term. And I say here, your eye may betray you, so remember the rule. So here's the problem right here. Here's an example of a problem. 5x squared minus 2x plus 4, that polynomial is to be, you're supposed to subtract from it 7x squared plus 4x minus 8. People who can handle addition have a little bit of trouble with subtraction. Look what happens. The way I wrote it is, it's the first polynomial, okay, minus each term of the second polynomial, and this is what I'm indicating right there at that stage, and then I write it all out, because we remember things like minus, a minus turns plus, etc. But look what happens. When you subtract this polynomial, 7x squared plus 4x minus 8, the 7 turns to minus 7, the 4 turns to minus 4, and the minus 8 turns to positive 8. All three of the terms of the polynomial being subtracted change sign. Then you combine them and get your answer. Okay, I'll let you look over those notes. And then finally I go, of course, you don't have to write this all out. It's a pretty quick exercise. So think of it as when you're adding two numbers, 238 minus 112. We just do it we do it column by column, don't we? We go, I say plus, let's make it plus. We get a 10, carry the 1, we get a 4, 5, and then we get a 3. So basically you're doing the columns. Why? Because these are the ones, these are the tens, these are the hundreds. Well, these are the x squareds, okay, and they get combined. These are the x's, and these are the numbers, okay? So it's the same thing. All right, so when you're adding these things together, here's a couple of examples I'm going to do, and then I'm going to stop and let you do some examples. And I think we do a fraction problem, then we're going to be done, okay? So it says, the word doesn't say, sometimes it says simplify, it might say add, in this case it might say subtract, but when you want to train your brain to look at this and go, oh, I'm adding I'm subtracting two polynomials. So with practice, you'll see it and go, this is routine. You got to practice though. I'm going to show you a way to do it. You don't have to do it this way, but I learned it from students. So what they do is they go, okay, first of all, I'm adding two polynomials together. I see this sign right there, okay? So what they do is they take the second polynomial, and they actually, like we did with the numbers up here, they write it underneath. 18x squared minus 6x minus 10. And what they're going to do is they're going to add. They're going to add. So you do your numbers. Minus 12 plus 18, or 18 minus 12 is 6. Remember, you're just combining like terms. The power doesn't change. You're saying, how many x squareds do I have? Just like in the arithmetic here. How many hundreds do I have? 3. That's how many. How many x's do I have? Well, I got to go minus 4, minus 6. Got to know how to do that. You can use your calculator. Minus 10x. Finally, I've got 9 minus 10 minus 1. Full credit, A+. There you go. Okay? That's pretty straightforward. And I know some of you don't do it that way. You just go, I just do it in your head. Or you get rid of, you don't have to get rid of parentheses, things like that, and be all crazy about it. Now, watch me do a subtract problem. Okay. Here's where you do have to worry about parentheses. I'm going to draw a little diagram here. What am I doing here? Is I'm indicating, since I'm subtracting, okay, since I'm subtracting, I'm going to change the sign of each term. That's what students do. Change the sign. So here's where the eye deceives. You go, oh, it's minus 18x squared. I'm going to tuck it underneath, minus 18x squared. But then students will go, minus 6x minus 10. No, it's minus a minus, so plus 6x, minus a minus, plus 10. So all of a sudden you realize, oh, when I subtract, this is where you add the opposite. It's a shortcut. It's a nifty thing. If you see subtract, change their signs and then add. Okay, then add. So it looks like minus 12 minus 18 is minus 30 x squared. Minus 4 plus 6 is plus 2x. And 9 and 10 make 19. So I noticed that I put the same polynomials. One is add and one is subtract. And this is how this is done. Okay? So you can pause and stare at that. Here's your turn. Now what you should do, once you're done looking at what I did, think about it, and then pause your video and do these problems. Okay, I'm going to let you pause. Okay, now I'm going to show you how to do these. If I'm in a hurry, I just simply do the same thing. Okay, so this is us working on it. I'm going to do the same thing. Since it's subtract, I change the signs. 2x squared minus 7x plus 4. And then I add, you don't have to write this, add the opposite. That means I'm just adding. So 8x squared, and then plus 5x, and then minus what, 14? Did you get that? I did. I think we're good. Some people do it in their head. They go 6 minus a minus is plus, 12 minus 7 minus 18 minus. It's too hard that way sometimes. It's better to change the signs and then add. And then here's another one. It's a little bit strange. Of course, I do that to you all the time. I'm going to take now. I wonder if you figured this one out. Because since it's just add, I just write the terms of this guy underneath the other guy. But I don't put the 9x squared under the x. Why? Because he's like the hundreds and he's like the tens when you're adding numbers. Okay? It's like you're adding like something. Well, I can't do that. I'll just do this. I'm going to put the 9x squared, though. I'm going to put him way over here. Then I don't have an x term, so I don't put anything there. I just gave you a sneaky one, didn't I? And then I'm going to put the minus 8 under the 10. So I'm going to add, and what I'm doing is combining like terms. I don't add the 9x squared with the minus 6x. I simply drop this guy down, drop the other guy down, minus 6x, and then finally, oh, look at that. Oops, I made a mistake. I don't know what I'm tripping. It's morning. What can I say? This should be a minus 8, right? So we should get a 2. And that's it. Hopefully you got that. Pause, 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 right? All right, we're going to do one more. It's a short video on how to add this stuff so you can take your time staring at it. And this last one is about, what about fractions? What if I have to do fractions? Well, you might have to do a little extra work, or maybe you're good with your calculator. But I'm doing it the same exact way. I'm going to go, oh, look, it's a plus. So I'm going to write 3/8 x squared minus 1/2 x minus 2/3. And I'm just going to add. But the problem is, oh, I have to add 5/4 with 3/8. Bummer. So you're probably going to have to go to the side here and go 5/4 plus 3/8. I need a common denominator of 8. So 10/8. What did I do? You know what I did. I hit him with a 2 and a 2. Okay, a 2, bless you, plus 3/8. And I'm getting 13/8. Okay, that's part of our answer. Believe it or not, 13/8 x squared. That's how you do these guys. The next one, I got a minus 2/5. Oh, let's do it in the same kind of color scheme. All right. Minus 2/5 minus 1/2. So they're going to bunch up and become larger. The common denominator should be 10. Notice they're both negative. So what do? Well, I have to hit this guy with a 2, this guy with a 5 to get a common denominator. And we're getting minus 4/10 and minus 5/2. Add together is minus 9/10. Okay, minus 9/10 x, and one more. We get to do 1 minus 2/3. That one's about the easiest one because I can do it in my head. It's 3/3 minus 2/3 is 1/3, and that's what we had, plus 1/3. And there she blows. I think that's it for this particular lesson. Okay, so I'll stop the recorder.